Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight Podcast. I'm your host, Eric Walenza, CEO of IoT One, and our guest today will be Neil Sahota. Neil is an IBM Master Inventor, an AI subject matter expert with the United Nations, and a member of the faculty at UC Irvine. He's also the author of the new book, Own the A.I. Revolution, which explores how companies can integrate AI into their strategies to realize new competitive advantages. Together, we discuss the current state of AI in practice, the integration of IoT and AI technologies, and the importance of new data sources that are designed for use by machines rather than humans. We also explored the importance of assessing social impact while developing and deploying disruptive technologies such as AI. I hope you find the conversation valuable, and I look forward to your thoughts and comments. Neil, thank you so much for taking the time to speak with us today.
Yeah, I'm excited to be here, Eric. Thanks for having me on.
So Neil, I've been thinking, what is a good way to start our conversation? We're going to be talking today around AI generally, but that's a huge topic. So we'll focus more on the relevance of AI and IoT and industrial. But before we get into that topic, I want to give our listeners a bit of a background into who you are, what you're about, and then why you're with us today. And I know there's a few topics to touch on, but we recently published a book, Own the A.I. Revolution. So maybe if you can give us just a little bit of a background on your path to this point, and then what led you to put in the tremendous amount of hours required to publish a book like this. I think this would help our readers understand where you're coming from into this conversation.
Well, that's an interesting question, Eric. I will say that I kind of got into all this by accident. I definitely didn't plan to be on, one of the, I guess I'll call it pioneers of the AI wave. I've always been kind of the guy to try and solve problems, but try and solve them generally rather for a specific situation. And so as a result, I developed a lot of IP and other types of things. And about 14 years ago, when we saw a takeoff in business intelligence, because we could collect, store, slice and dice, and report on data, a lot of people said, wow, it's amazing what computers can tell us. And I'm thinking to myself, well, they're not actually telling us anything. We're just manipulating information that we have, but could a machine do that? And so I wound up developing like a series of patents around what we call machine learning today. And, lo and behold, there was a secret project going on at IBM. Turns out there was some synergy in my work there. And next thing I know, I'm involved in IBM Watson. And great experience. See a lot of opportunity, was one of the champions for creating, like the IBM Watson and the whole AI ecosystem to try and basically add new capabilities and services for people. And in doing that, what I really realized was it's not so much about the technology. The technology is a tool, but felt like people would struggle and try to understand these new capabilities. AI is called the third generation of computing with good reason. It's very different than just executing a program. Machine ability to do kind of, low-level tasks with some cognition that we're not used to. And so it's a different way of thinking. So working with global Fortune 500 companies and nonprofits and startups, government agencies of the United Nations, I realized they had a lot of the same questions, same concerns. But one of the big things was, I know I should be doing something. How do I figure that out and how do I get started? And so that's why I actually decided to write my book on the AI revolution, because rather than trying to work everything one-on-one, I saw this as an opportunity to share this knowledge so people could actually get a leg up on figuring out how to answer these questions.
You have, I've got to say, one of the more interesting LinkedIn profiles that I've come across. You're really, you're very active. So you're a lecturer at UC Irvine, but then you're also involved as a board advisor or somehow as an advisor at quite a number of organizations and companies. And there seems to be, and maybe you can help me understand the logic behind this, but there seems to be two big themes here. One is AI, or companies that are somehow using this set of technologies. And the second is social responsibility, or companies that are trying to do good while also running a successful business. How does this reflect your time right now? I mean, how active are you in these companies? And then how does this align with your more general academic or intellectual interests?
That's a great question, Eric. I know it may seem hard to believe, but they're actually all connected together. I really believe we have a chance to shape the future. I know a lot of people are always concerned, and most of us, we're afraid. Maybe fear is not the right word, but we're concerned about change, and it's happening faster and faster. But I actually believe that each of us have the opportunity to shape the future. And where I see the most innovation, or if you prefer disruption, is actually with the startup community. They're willing to challenge the assumptions and come up with not what I call automation, finding ways to make an existing process, system, or product faster, cheaper, less errors, but find a different product, process, or system to do the work. And because of that, that's why I've been so ingrained, helping up startups, being an advisor, actually trying to help these people figure out, how to build a viable venture to make that a reality. At the same time, my goal in life is to try and leave the world at least as good as I found it, if not better. I really feel fortunate for the opportunities I've had in life and some of the mentors I've had, and I want to try and pay that back and encourage future generations and future leaders to do the same thing. And that's why I'm really big about social good and championing social enterprise and social entrepreneurship, because there's nothing wrong with making money, but I think there's an opportunity to make money and help our community, help society, help the planet as a whole. We just usually don't get that kind of mindset or that kind of exposure to us. And I think cultivating that is really important. And both these things really tie a lot to education. And I really feel it's important that we keep our curriculum fresh, we get people ready for the future of work, but we give, students and, future generations the knowledge, the skills, along with the tools to make this future a reality. So, from my standpoint, I'm able to juggle these three things because I really see them as interconnected and part of a much larger ecosystem to help make that world at least as good as, if not better, than I found it.
This would actually be an interesting machine learning or AI challenge, this issue of properly evaluating a company's value to society, right? Because right now we have a fairly simple mechanism for doing this. So how much will somebody pay for their core offering? And then we have some costs associated with running that business, but externalities are really not factored in very well, right? So some companies or some industries have a lot of negative externalities that never show up on their bottom line, and others have a lot of positive externalities that they're for some reason not able to monetize. And if we had a system or a solution that was able to more granularly evaluate the impact or the value of a particular company society, this might actually make social enterprise, or let's say companies that are trying to do good as well as make money, appear much more successful, right? So this is, I think this externality challenge has been just a key challenge for governments and intergovernment agencies for hundreds of years, ever since they've started trying to regulate. And it's always been people, lawmakers trying to set up, laws. So kind of this Byzantine structure of laws to try to regulate what makes sense and what doesn't. But they always seem to be lagging a little bit behind the industry, right? Because they're always somewhat reactive, and they react with the speed of Congress, and the speed of Congress is not, that's, you're always going to be, 5 years behind any particular trend. I'm curious this is coming a little bit out of left field, but I'm curious whether you've ever thought about the application of AI to these more social level challenges of how do we, for example, evaluate externalities and price these? seems to be something beyond beyond human cognition to some extent.
It's actually a great observation and a great point, Eric, and a really poignant question. Ironically, it's actually something I have thought about because, we're now dealing with a space where machines are making recommendations and in some cases, potentially decisions. We can't afford to be reactive. We have to try and think through what might happen. And that is actually a big challenge, especially, we talk about people that may not fully understand the potential, the possibility, or understand the technology. And I've actually thought about this. Could we create like an AI system to help us figure out what people might do and kind of, be the AI philosopher and anticipate so we can create good, regulation, good policy? The challenge, though, is we don't know how to teach AI imagination. We don't know how to teach an AI creativity. That's the realm of, we call AGI, artificial general intelligence, which we haven't cracked yet. And AI is really good at what we can teach it to do. And that's all it can do. It can't do anything more than that. That's a major constraint in trying to make this happen. The other thing is the variability, right? When we teach AI, we have to be able to give it tons of data to learn from. We have to bring the subject matter experts. But if we ourselves can't anticipate and if we can't teach imagination, it's unfortunately a really tough egg to crack. However, I always feel like there's a path forward. And one of the things I've been thinking about is if we can't create that kind of AI philosopher, could we create that AI questioner? Could we create an AI that would at least bombard us with questions and kind of go through this, whether you want to call it critical thinking or thought exercises to kind of flesh out, no matter how random it might be, different things that might occur, that might actually be possible. And I think that's actually a good example in that I know a lot of people are worried about, is AI going to replace me? It's not really about that. It's about human-machine collaboration and using AI as a tool to help us, do more complex, more value-add work. And I think an AI questioner that could, pepper us with, very relevant, sometimes maybe really, far out there questions to flesh this out might actually be a useful tool. Because it's sometimes hard for us to think about the extremes that might occur, if nothing else, the craziness that people might do with technology.
Yeah, that's a great point. It really touches on one of the key challenges in thinking about how to make use of AI. I think a lot of people want to be able to develop an algorithm that plugs out a specific number and say, okay, this is the number. Let's go execute on this. But this thought process of figuring out what type of output is actually feasible and would provide value. And it might not be a specific number at all. It might be directional. It might be a set of, a set of questions or a set of impulses that is actually more feasible than trying to develop a system that it will tell us the answer. And this is probably the right way in many situations to actually think about the use. But I think it's not intuitively how people think about AI. People tend to think about AI, you put in a bunch of data, and then it says this company has a score of this, and that company has a score of that, and go implement on this. I'm curious, Neil, when you work with the UN and other governmental or intergovernmental agencies, how receptive are they to adopting this type of solution? Are they actively seeking solutions? Are they actively engaging this topic? Are they somewhat hesitant or maybe not particularly informed about what is possible today? What's your experience in working kind of at the interface of, let's say, intergovernmental agencies and AI?
Well, I would have to give the typical MBA answer, and it depends. It actually, unfortunately, depends on the agency and the leadership themselves. I've seen a lot of agencies, in the US and around the world where they're really hyper engaged. They see this as a phenomenal opportunity to enhance or even provide new public services for people, do some things more effectively, more cost effectively as well. And they're actively pursuing that. They actually have projects and in some cases some products out there. For example, Singapore is leveraging this technology to help direct traffic, to reduce congestion, which actually has the also benefit of reducing carbon emissions. So fantastic stuff. I know that organizations like, the state of California and the Department of Defense, Department of Agriculture are actively working on projects and initiatives to enhance public services. But you also have agencies out there where they're slow to move for a variety of reasons. They might be concerned about, bias within the AI or the truth and trust in the technology or disparate impact, for example. Like one group might unfortunately be more definitely harmed by it. And then you have some agencies where they're not really doing anything. It's not really on the radar. And for a variety of reasons that, could say, some of it might be cost, but some of it might just be like they don't feel like that AI could add anything. In some cases, it may not, but in some cases, it might. But they don't believe the machine can do something better than a person. And don't get me wrong, I'm not advocating that machines do everything better than people. There are quite a few things people do better than machines. But some of the things that machines do better than us is surprising. And I think our own limitations or our own perceived constraints sometimes inhibits our ability to do that. Like, for example, we've actually found that people are more honest talking to an AI, like a chatbot. It doesn't matter if you're a doctor of 20 years, you're a lawyer of 20 years, or accountant of 20 years, they'll actually tell the AI something they would never tell that person. Think about your doctor's going to say, hey, minimum for 20 years, just do a routine health assessment. They might ask the question, well, on average, how many drinks do you have a week? We'll be like, I have a glass of wine socially, that kind of stuff. But when they talk to an AI chatbot, they're like, oh, yeah, I have 3 whiskeys at lunch. And it's just like, it's surprising because why wouldn't they tell the person? But we realize they feel like when they talk to the machine, there's no judgment involved. And as a result, they can actually be more honest to provide better information in that regard, which means better information means better insight, better things, better ways to try and help the person with whatever their needs are. It's tough for us to accept that sometimes another human being will be more honest with the machine than ourselves.
Very interesting. So I think we can start to get into the deep end fairly quickly here. So let's lay a little bit of a foundation first with the question, what is AI? Because I think we can get into the habit of just using this term AI around a lot of different use cases. But for many of our listeners, this is not their area of expertise. For me, it's also not mine. And so it's useful to know when we say AI, what are we actually talking about? What are the suite of technologies? How do you frame this? When you think about this, how do you structure this concept of AI in a useful way so that you can say, here I'm talking about AI, but I mean this, and here I mean that, alternative set of technologies or use cases.
Thanks for keeping me grounded, Eric. It's a really pertinent and important question because the definition of AI is a bit of a moving target. As we develop more capabilities, it kind of shifts. But at the end of the day, AI is about a machine able to essentially mimic human thinking, that it can do tasks that require some level of cognition without direct human intervention, so to speak. And this typically means that there's 3 things involved with AI. The first is machine learning. Machine actually learns by reading, by watching videos, by hearing, and by doing. So much like we do. You basically give the AI a bunch of data, it draws a lot of conclusions, and then it works with human trainers trying to do things. As it does things, you have domain experts who are like, well, this is right, that's great. Well, this is wrong, this is the reason why, this is the right answer and why. This is a good answer, but a better one would have been this is the reason why. And you got 3 of the 4 things over here, but you missed this 4th thing. But the thing is, it learns really fast. And it's not about programming. It's not about giving a set of instructions. You just give it rules on how to make decisions. You give it a whole slew of information, data is the fuel for AI, and that's how it winds up working. That's how it learns. The second thing is the ability to understand natural language. We don't realize how difficult that is for a machine because think about how we actually talk. You use a lot of slang, you use a lot of jargon, a lot of idiom. If I say, hey, you know what? I'm feeling blue because it's raining cats and dogs. Guess what a machine thinks? The AI is like, wait a second. Yellow's physically the color blue because it's raining small animals from the sky. That doesn't make any sense. That doesn't compute. But with AI, it's not looking at the keywords. It's looking at the intent, the context of the conversation, the connotation. It's not looking at things as literal meaning. It's trying to derive information, the subtext, if you will, about what's being discussed. And that's a powerful tool within AI. And the third component is the ability for it to act like it's another human being, that we can interact that way. For better or worse, search engines like Google have taught us to rely on keywords, but it's not efficient. If you think about Alexa, I could say, hey, Alexa, turn down the lights, and it'll totally turn down the lights, right? But if I say, hey, Alexa, it sure is bright in here, it doesn't realize that I'm really implying it's kind of bright. Can you dim it down a bit? So, with AI, it can come back and might say oh, whoa, hey, Neil, you think it's too bright? You want me to turn down the lights? I might say, yeah. Or if I'm looking to buy a bicycle, go to AI that knows about bicycles and say, hey, I want to buy a bicycle. Which one should I get? It's like having a best friend that knows bikes, and it'll come back and say, hey, Neil, why do you want one? I want to get back in shape. So great. How often do you think you'll ride it? I'll probably ride 4 or 5 times a week, maybe 45 minutes at a time. Awesome, Neil. And where would you ride your bike? I'd try around my neighborhood. And it'll come back and say, Neil, here's the right bike for you, right? So it knows about bikes, it's seeking more information, but it might also know things about me. That's why I say best friend. It probably knows that, Neil doesn't like to spend a lot of money, so I'm going to exclude expensive bikes. I also know that Neil says, 4 or 5 times a week. He's a pretty busy guy, so it's probably once a week. We factor all these things to come up with a good, personalized recommendation, a best fit for my need, than just a blanket type of thing. And so it's these abilities combined together that allow the AI to actually, answer questions or solve problems we don't have the answers to. It's not a giant search engine just spitting back things we know. It's actually trying to solve problems, help us find answers.
The first one, machine learning, is, let's say, a very fundamental method of writing a general, kind of to some extent, a general algorithm with some really fundamental premises, and then turning it loose on data and going through this training process. But you're not building in a lot of logic into that algorithm up front, right? You're building in some fundamental logic, but then you're allowing the training process to build the algorithm as you go. The other two, how would you build these up? Would it be a combination of machine learning of, let's say we have Siri in the home, or Echo, or Amazon, and through interaction with people, it starts to understand that when you say something, typically it gets the answer wrong the first time, and then you rephrase that using another terminology, and then it understands you. Therefore, it starts to associate those two terms through this kind of learning process of just being in millions of homes and having these daily interactions. Is it still the machine learning process that's training it, but then maybe there is also some more traditional AI or kind of programming under the hood of, okay, and then we'll also connect this to your bank account, so maybe it knows how much money you actually have. If you want to make a purchase, it knows what's financially viable for you, and then we connect this to your Facebook account, so it knows how many who your friends are and what they tend to do and so forth. So my point here is machine learning is this one process, and then we also have more traditional AI processes of saying, okay, I'm going to connect these different databases and give it some more direction in terms of what data to assess in a particular situation. So how would you go about building, let's say, the third app that you were talking about, where you have kind of a conversational application around maybe purchasing a bike as an example?
Great question, Eric. A lot of this has to do with what we call classification and concepts. And classification is just trying to order some of the data to help the AI understand. But what's actually more powerful is this concept training. And with concept training, we're trying to teach the AI the associations. So, I used the example earlier about, I'm feeling blue because it's raining cats and dogs. Blue could mean a color, but it could also mean an emotional state. It could also mean, a reference to music and so forth. And it's these associations that we need to teach the AI as kind of or I should say, as part of the natural language understanding. To use a different example, you think of France, right? If you were to ask just a regular machine, what's France? It would spit back a bunch of facts. Okay, it's a country in the European Union. Its population is, 50 million people, 30 million square kilometers, whatever it might be. But if you ask a person what's France, they may not quite say the same things, right? They might, oh yeah, it's a country in Europe, but it's also red wine. It's the Louvre. It's the Rhone River. So it's the Eiffel Tower. And these are the important things to teach the AI, is this conceptual training, so it has to make those associations. So to be able to have a conversation and to give it a sense of personality, it has to kind of understand the way conversation works, the intent, the context, but have the banter, right? It's not just necessarily asking a series of questions, but make it a natural flow. That you might teach the AI is like when you engage in a conversation, you don't just dive into the information. You might like, hey, great, how's it going? Maybe a greeting, like, oh, cool, you want to get a bike, right? So it's kind of teaching, for lack of a better word, the psychology on how conversation actually works. So there's definitely an element to machine learning to all this, but what we take for granted, what's second nature to us, is actually really complicated for a machine. Because think about it, how many different ways could a conversation go? You walk up to somebody you may not know and you say like, hi, how's it going? How many different possibilities are out there, right? And for a machine to understand and learn how to properly react in each situation, that's complex. That's why we definitely need machine learning, but we have to be able to teach those concepts to the machine at the same time.
Yeah, it's interesting that we're almost on opposite poles in terms of what is easy and what is difficult for human and machine, right? So the things that are the hardest for us, complex mathematics are very simple for machines and vice versa, right? So we have a lot of specialized modules built into our brain after whatever, a couple 100,000 years of evolution that are make it fairly intuitive for us to have conversations and read people's emotions and so forth. And we don't have modules for how to do algebra, right? Or not specialized modules. That just hasn't been around long enough and been useful long enough for that hardware to be built into us. But obviously for the machines, this is quite different. So this is, of course, quite difficult for people, I think, often to grasp that there's this kind of dissonance between what is easy and what is difficult. If we use this example, maybe dig into it a little bit more, there's some things there that are probably fairly easy for a machine. So it's able to grab all of the relevant information, whatever is available online. It's able to, if calculations are needed or something, so around the population of France or anything like this information is relative available. And some are quite difficult. So today we have, I think, a balance when building a solution, which is mixing some degree of machine learning and some degree of human coding, of just saying, okay, I want to produce some specific result. I want a functional technology that is conversational and human in its approach. And so there's some degree of coding in. What does that look like today? So if you were working with a startup to build this team, to what degree would they be building kind of a basic structure and then just pumping in millions of conversations, or somehow using large data sets to train? And what areas would they be manually coding this in order to help the solution accomplish goals that kind of a brute force training is not going to accomplish at this stage in the development. And I ask this specifically because it's also a challenge for me. If I'm doing a project, it's kind of unclear where can we trust the algorithm and just say, okay, we've got these big data sets and we're going to put these into the into the algorithm and it gives me something out. But then there's places where we have to step in and really get quite heavily involved in trying to craft the logic. And it's generally, I'd say, unclear where it's best practice to do that. So maybe if we can use this example to illustrate a little bit where we should focus on machine learning and where we should focus on on developers being deeply engaged in designing the AI solution.
That's a great question, because training is one of the big challenges around AI, and people tend to underestimate effort around it. Right? AI, unfortunately, is not just a magic box. It just does whatever we want. What we really need to focus on is what we call the ground truth. And the ground truth are rules on how to make decisions. They're not the decisions themselves. And basically, that becomes the literal truth for the AI. So you think about it, if the AI is like a 3-year-old kid, you're trying to explain it to a 3-year-old kid, right versus wrong behavior, you try and give the child rules on, like, don't hurt people, right? It's not specific behavior, but it's like hurting people is bad. That's a rule to follow, a guideline on good versus bad behavior. So we try to do the same thing with AI, and we try and use a cross-functional team to teach the AI. So as we give it information, depending on how much variability or the complexities around it, we might annotate some of it to call certain things out, like good behavior versus bad behavior. And so that's part work, data scientist, part work developer, but also part work domain expert. So when it comes to AI projects, it's not just we get requirements, tech team goes out, does design and build stuff. It's very much an integrated, we need everybody involved along the way. And we just let the AI actually try things, and we see how well it does. We essentially are looking for a level of confidence in how well it performs. And some AIs actually will tell you that I'm 50% confident in my answer, or 70% confident in my answer. We keep going through this cycle of training it more and more complex things until it gets to a level of confidence that we are confident with to let it be used for general use. Now, it just depends on what the impact might be. If we're talking about, a chatbot trying to help out with customer service, we might be okay at 80%, right? It will keep learning and get better. And if it runs into a problem, we have an alert human customer service rep. But you look at healthcare, where people's lives are at stake, 80% is probably not sufficient. So we have to invest a lot more time in doing that to probably get it to 98%. So, when I was working with IBM, and one of the first things we did was, healthcare, and talking about how Watson could help with cancer research, we had to teach Watson about cancer. And there's a lot of different forms of cancer. There's different stages. There's a lot of a lot of different information, a lot of variability involved, a lot of complexity. So it's not a fast process. Then you add to the mix that the people that are really the subject matter experts here are extremely busy, and we just can't pull them off their work because they're working to try and save lives. And so between the combination of, limited subject matter expert time and the vast variability in the world of cancer, it took several months for Watson to get up to a decent proficiency around that. And that's one key thing you have to learn. It's AI out of the box is not going to just know stuff for you. It's not going to be able to do things. We have to invest the time and effort to actually make that happen. And the more complex it is, the longer it takes, which is why I always recommend to people, it's great to think big, but start small. You start on a small subset. Could you pick one form of cancer, like pancreatic cancer? Could you pick one stage, like maybe stage 1, and focus on teaching that really well, and then building upon that with more and more layers.
And I imagine this is, you'd mentioned earlier that some agencies are heavily engaged and some are not. And I imagine for a lot of agencies, they simply don't have the specialized resources, right? The data scientists and personnel to approach this, or at least they don't feel that they do. Whereas if you're talking about Department of Defense or Bank of America, of course, they have the resources to invest. What is the state of off-the-shelf solutions? Because there's a lot of medium-sized companies and also a lot of medium-sized organizations, say government or organizations. If we think about, a police force in a small town or a medium-sized manufacturer who have a lot of deep expertise in their particular domain. So they have half the equation, but they don't have the ability to go off and hire 5 data scientists. What's the best practice if they wanted to get involved and they had a limited budget? Would they be able to purchase something off the shelf that would help them with maybe just kind of, 1 or 2 developers who are not PhDs, but maybe have 5-10 years of experience to begin to build up solutions? Or does it really require a pretty robust effort at this stage to build something up?
It really depends on what you're trying to do. A lot of the big tech companies, the Googles, the Alibabas, the IBMs, have been really good about creating APIs for people to use. The API gives you a specific capability, mix and match, use what makes sense. But what I've seen in my own experience is just no perfect solution. You just can't mix a bunch of APIs and get exactly what you want. There's always some level of proprietary or customized for exactly what you're trying to do. The APIs might get you 70 to 80% of the way there, but you still need those resources. Now, the good thing is there's a lot of people working to try and create these ecosystems. Google, IBM, Alibaba, all these guys provide help, support, guidance, but sometimes that's not enough. And you can't just go and hire 5 data scientists like you said. But there are other organizations out there that, either they're medium-sized or boutique consulting firms that could be supplemental, or you have organizations like Omdena that they're trying to take the opportunity where you could sponsor a challenge or a program at a much reduced cost than trying to hire, one of the big tech giants. And what they're doing is they'll help you solve that, but they're all at the same time, they have some good people, and they got some people they want to upskill, especially underserved communities, to learn the skills. And so they see this opportunity that, we can help you. We can also leverage these people that want to give back and teach people these new skill sets. And so I'm seeing more of this, ecosystem type of play to actually create value across the board. And so if you're a medium-sized company, or agency, or a startup, there's a lot more of these opportunities, especially on a global scale, to get the help that you need.
That's interesting. And you said they have communities that they're trying to skill up. Why is that? Are these, because I'm not familiar with this organization, is this people internal to their organization that they want to upskill? Or is this, are they kind of a non-governmental organization that's specifically trying to help particular populations develop these skill sets?
It's very much the latter. They're a nonprofit, and they're trying to take the opportunity and say, look, we know future work is changing. We know where the skill set demand is. People in a rural community or underserved community may not have the same access to education or experts. We want to create the community, but give them also the opportunity to learn hands-on by connecting them with that and real-world projects. And so Omdena's goal is to actually help these populations get those skill sets.
Interesting. Yeah. One thing that I've seen that is not maybe as benign, but might be actually effective in some cases. I'm interested in your perspective on this, is companies that are willing to take on some of the workload or the cost of developing AI solutions in return for access to the data, right? So I see more companies coming out with kind of productized AI solutions where they'll go in and they'll do some system integration work that's, probably not profitable, but by doing this, they're able to get more data into their system, better train their system. I know from the end user perspective of the company that's employing them, this is always a bit of a concern of if I, maybe on the one hand, data is this beautiful thing where it can provide value to me, and I can transfer it to somebody else, and there's no cost to me, and there's additional value for them. So it has this wonderful property of being able to provide value to multiple people with a really negligible transfer cost. But there's also this uncertainty around, if I do that, am I losing control of something that I don't understand, right? So maybe I don't properly understand the value of my data sets or the value of having proprietary, access to this data, and am I then giving this up to another organization, or even giving up the competence to understand the data, and then I'm just a receiver getting the output, but I don't really understand the underlying logic. How do you? I mean, this is maybe a complicated question that gets a bit into business strategy of where a company wants to go with their approach to managing data. But how do you look at this situation of companies that they have data, they want to extract value from that data, and they have somewhat of a trade-off of potentially giving up access to that data to a third party who would then also have access to their data, but in return they would actually get a functioning solution. Do you? I'm not sure if you advise companies or come upon this question of when do I give up access to my data? How should I value proprietary access to a particular data set?
That's a really great question, Eric. And I wish I could give a one-sentence answer, but it's complicated. I mean, data is the new oil. And if you're a young entrepreneur, it's really hard to get money and resources. It's a really good deal, and it might be. I mean, you have to really try and weigh, but the challenge that I think everybody has is what's the real value of the data? Just being able to have it and collect it and store it and slice and dice it up doesn't mean that we necessarily are collecting things that are meaningful. It's actually, this is something I teach to my MBA students. This is the real challenge, but everyone just knows they want to essentially hoard the data. If I have more data, something good will happen. Not necessarily the case, but I think the bigger challenge is if you do this, what will that other organization do with the data? Are they suddenly putting you in a liable situation? Interestingly enough, actually just this morning, I was talking with a rather large company, I won't name names, and they were working with one of the very big management consulting companies. And they were asking me look, they're willing to help us out with some AI stuff. They're willing to do things at a very cut rate, but they're very insistent on they get the data, that we have to share the data, they can use the data, and we don't understand why they even want the data. And I was just telling them data is perceived to have value. The more you have, the more it's worth, even if you don't know what you could do with it. And I was just telling the concerns around data security and privacy are a big thing, but maybe they see something or maybe they don't, that you don't, and then they want to take advantage of. But by the same token, this data hoarding has inhibited our ability to actually make advancement and innovations in a variety of fields like healthcare, where we actually know now beyond a reasonable doubt that a lot of the clinical researchers, the hospitals, the medical schools, academia, pharmaceutical companies, they're replicating other people's research, and in some cases 4 or 5 times without realizing that it was a dead end because people don't share information. We can't make strides in medical diagnosis and treatment and potentially even cures because we don't have large enough data sets because nobody wants to share their data. Disruptive PHI, personal health information, they think their data is so valuable that they don't want to contribute to an aggregate. Think about a public repository, again, disruptive PHI, where anybody could access and potentially accelerate the ability to cure cancer or cure AIDS. So if nothing else, we've placed a lot of value on data that it might be a bubble market, so to speak, that we're actually overvaluing the data that we actually have. So I get the concern and agree in a lot of cases that you shouldn't just necessarily give things away, make sure it's a good trade-off. But in some cases, we're impeding ourselves to actually make meaningful, life-impacting changes or benefits for our society.
Yeah, right. Well, it's a lack of transparency, right? So what is this data worth? I have no idea. It could be nothing, could be a lot. I've seen a couple companies, a couple of startups in the past couple of years that have in particular segments been building up something that I look at as kind of a IoT data, let's say Google for IoT data. So one is, I think, focused more on transportation. So they're aggregating data from different, primarily public transportation sources, but I think their intent is also to get private data sources and then allow people to access particular data sets through an API for some fee. And part of that fee would go back to the original data source. So then you would have a mechanism to actually be incentivized to share this because you're monetizing data that otherwise it's just sitting in some lake. And as long as there's no particular risk to this, and this in this case would be quite, I think, quite risk-free. This could be quite beneficial for all the government agencies that are investing a lot of time to collect data. They'd then be able to, to monetize this and sell it to, for example, automotive manufacturers or who want to figure out how to design better cars. Another company that's doing this is in the retail space, and they have a device that connects between a computer and a let's say a point of sale device, a computer, and the device that prints out a receipt. And so every time a transaction goes through this, they're able to collect that transaction level data that, whereas before maybe once a week you'd have an output report from a store, and they then provide this back to the company, but then potentially, depending on the contract, they could also aggregate this data and have kind of a data set of what do all of the malls in China look like in terms of consumption patterns. And so I've been seeing more companies experiment with this. It's going to be very interesting to see what the market accepts, right? But to some point, there seems to be a huge amount of potential value in figuring out, solving this problem of how do we share access to data in a convenient way and properly value. So I'm sure we'll come up with some solutions. Hopefully those are, we'll see how, I guess people are not universally satisfied with the solutions we came up with for internet data with Google and Facebook and so forth. So hopefully we come up with solutions that we're more or less satisfied with in this case. Maybe this can bring us to the AI and IoT data, because that's, I think you mentioned earlier in our talk, a lot of the data that we've been working for wasn't created for machines. It was created for people. And now we're kind of repurposing this for machines. But we have now, for the past several years, a very significant increase in sensors that are collecting data specifically for the purpose of machine processing. What do you see in terms of the AI IoT interaction? And I guess we can talk about this in terms of use cases, but also maybe at a bit of a higher level, just in terms of how this is forcing us to rethink what data is, what data should be, how we structure, how we capture data.
Well, I really believe that IoT and AI go hand in hand, right? Data is the fuel for AI, and IoT is all about generating data, especially for machine consumption. One thing we've learned about machines like AI is they think differently about something, but they can process, obviously, large sets of data, all these things, but they can do things differently because of that. To try and think of a simple example, we can look at self-driving cars. So as people, we really rely a lot on our eyes, and so we're very visual drivers. And when we started the foray of self-driving cars, there was an over-reliance probably on camera data. And people might have heard of the Tesla that was on autopilot. I heard the driver was watching a Harry Potter movie, but the driver didn't notice that 300 yards ahead was a truck that had turned over. The truck bed was blocking the highway. Well, it was very obvious to see it, but the Tesla never stopped. In fact, it ran through the truck bed and ripped the top of the car off. And people were like, how on earth did this happen? And it's like, well, the truck bed was white and it was a cloudy day. And so in the camera eyes, the truck bed blended in the background. Or we know that machines don't need to rely on sight. If the Tesla had been using radar or LiDAR or even auditory, sensors, it would have detected it in a heartbeat and stopped in plenty of time, which is why actually today self-driving cars have these capabilities. In fact, it's actually known that you'll actually hear that little kid about to run across the street before you see the little kid. So the fact that we can take these different sensory inputs, we can take IoT devices in the road, on traffic lights, and other vehicles, landmarks, whatever it might be, and process that information in real time for an AI system. AI can process, we're seeing like thousands of inputs per nanosecond while it's driving. That's one of the reasons why we think that self-driving vehicles might actually be safer than human drivers, right? It's that power, all that data that's being generated. We as people can't consume it. We unfortunately can't use radar or LiDAR information, and auditory is really dependent on how good our car is soundproofed and if we're listening to the radio or talking with somebody. But for a machine, it's a huge advantage. And I think it's these types of things that are going to create, it's these IoT devices that are going to supply this vast of data for an AI to process. They'll make the AI efficient in some areas more so than the human is. And I think that's the true advantage, the true benefit that we'll be able to reap.
Absolutely. And we're really, really just at the start of this. As a last topic to touch on here, AI obviously has potential to be extremely beneficial, but there's a lot of I would personally see as valid concerns with AI around its potential impact on society. Maybe we can set aside the existential concern around actually being able to control a general purpose, but maybe just more in the AI, but in the near term, the impact on society. And I know that this is an area where you are personally, thinking quite a lot and talking to different agencies. If we look at it in terms of impact on our relationship to work, do you already see significant impacts? And what would you foresee in the coming decade in terms of how AI impacts our relationship to work, and then what we might be able to do in response in order to make sure that humans evolve or adapt ourselves in order to stay relevant and make sure that we're not sacrificing some proportion of the population to technological advancement and making them somewhat obsolete as kind of functioning members of society?
That's a great question, Eric, and a very valid and concerning one for a lot of people. I'll say that throughout human history, we've always been worried about new technology replacing people. Even the tractor, a lot of people felt that might be the end of farmers. But artificial intelligence, like I think all technology, is a tool. It's all about how we use it. We can use it for good, we can use it for bad. I don't think most people are just trying to replace people. I think they're trying to give them a tool so they can actually free their time to do more complex, more value-add work. And very much so, the future of work, the hot jobs, 10 years from now are being incubated right now. You think about 10 years ago, 2009, we didn't have Uber drivers, we didn't have social media marketers. That's definitely the opportunity. The downside is we know that some jobs will absolutely go away. You think about autonomous vehicles, we probably won't need taxi drivers, we probably won't need truck drivers. So what do we do with these people? There's probably some percentage of them that we could retrain for a new type of job. But if you're a 50-year-old taxi driver, a spouse and 2 kids, you can't really tell that person you got to go back to school for 4 to 6 years and learn these new skills. That's not really going to fly. And I think it's a real concern that we have to figure out what to do with these people. But more so, we need to act quickly, because a lot of people that I talk with, they think some of these changes are 15, 20 years out, and they're not. Change is happening faster and faster. We think we have more time, and we don't. Like self-driving vehicles, Singapore is already having self-driving buses and taxis. So we have a small window to help those that we can. And every day we delay, more and more people are going to fall into the bucket where we can't just retrain them. We have to figure out what to do and how we help these people. It's not an easy conversation, and there's things around universal basic income or other things. But the one thing I think hopefully everyone can agree is we cannot delay. And that is what concerns me the most. It's not that whole sales people, it's not like millions of people are still going to be out of work. It's like we have this opportunity right now to help a lot of people get ready for that future of work. Are we actually taking advantage of that? Are companies trying to look at the new skills and knowledge and retraining their workforce? Are we looking at trade schools? Are we looking at college and universities, even high schools, to get them ready for that? But I can tell you that at the UC Irvine, the dean of the law school has been very much a forward thinker. She was thinking about legal tech and maybe tools that the law students should learn, to make them more attractive to firms. When she saw some of the things that were going out there, like Legalmation, who's created an AI associate lawyer, she actually realized that fundamentally what law students are going to do in their first 4 or 5 years is going to be radically different in like 6 years. So she's actively working to change the curriculum, actively working with law firms and organizations to define what that future work will be. So I think inaction is not an option. And if we're really concerned about this, want to try and help as many people as possible, we should all be working towards that goal of defining future work and getting people ready for it.
No, that's a fascinating topic. Law, accounting, a lot of the areas that are most intellectually demanding are really the areas that are most at threat here, right? Because these are based on the ability to memorize a lot of information. And that's something that AI tends to be better at than humans. But very glad to hear that they're focused on this. And it really is this, right? There are unmet needs, right? So in law, for example, there's a lot of unmet need maybe around advising, counseling, understanding the human requirements behind a case that maybe we're not meeting so well today. And we could redirect some of these energies towards, I guess, is that the type of solution that you might be looking at in a situation such as this, of saying a lot of the work that was done in the past, which is looking up relevant regulations and laws, that will be done by the AI. But in terms of counseling individuals who are in a legal case, that might be then done by a person. And maybe before we were only devoting 10% of our time to this, but we can actually increase that to 30 or 40% of our time and give a much higher service level. Is that an example? Or what would be the examples of areas where in law we can significantly, or we can employ let's say the millions of young lawyers that are entering the market?
Eric, you're 100% spot on. People always talk about legal research and the management around the case rules, which is more about what's billable, what can be expensed. But even reading court documents, generating court documents, going through discovery information, a lot of it is very similar case to case, right? It might be 60 to 80% similar, but you could have a machine, an AI, basically take up that work and get you 68% of the way there. I mentioned Legalmation, which is a startup started by 3 lawyers. They're doing some of this work where they're able to take what normally takes like an associate lawyer 6 to 10 hours to do, they can do in 2 minutes. The goal is not to get rid of associate lawyers. You still need them, you still need partners, that kind of stuff. But by freeing their time up from this, where they're doing more of the review and filling in some of those 20% gaps, it frees up their time to actually talk more with clients, to think more about case strategy, to think more about like jury selection if necessary. So more of the complex tasks, more of the things that are probably going to be more influential for a case. Now you're freeing up their time to actually work on that. And, I know there's probably some people thinking out there, well, even then you don't need as many associate lawyers. I think then it's on now the firms to think, well, we have to get more business. If we can do more work at a higher quality at a lower cost, we can probably get more clients. get more efficiencies. And so there's actually more work than there was before for the lawyers to do.
At least we can look to farming as a positive example. We, despite the fact that only 1% of Americans are farmers, we produce a lot of food, and it seems to work, reasonably well. So hopefully we can evolve here as well. But we probably have to do it a bit faster, right? I think the change is going to happen a little bit faster here than it did in past industrial revolutions. Neil, I have a couple. I want to be cognizant of your time, but a couple closing questions here, which are a little bit lighter. But I think these are areas where you'll have some interesting answers for us. Before we go there, are there any big topics that we didn't cover today that you'd like to make sure we do cover?
I'll just call one thing out, Eric, if you'll indulge me for a moment. I know we've been talking about a lot of AI and the power, the opportunity, and the fear, and the concerns. I definitely want people to realize that, AI is just a tool about making money and commercialization. There's actually a lot that it can do for social good. One of the things I do with the UN is I help them start the AI for Good initiative. They have 17 sustainable development goals, like zero hunger and poverty, better access to healthcare, and so forth. That AI can be very much a tool to enable some of these goals to become reality. And I'm not saying making money or anything like that is bad, but I think there's a lot of opportunities for social enterprise, social entrepreneurship, where, even AI aside, we can get into the mindset of thinking about, I'm going to create a new venture, I'm going to make money, but are there any opportunities as I do this, I could also promote social good? And I think that's a really important mindset to get into, because when it comes to AI in particular, we're really good about thinking about the bad stuff we call scary AI, weaponization and loss of jobs. But we're not so good about thinking about the upside, right? Beyond making money, are there other things we can actually do to help society? Like, could we actually use AI as a career coach and help people get better jobs? So I just want to call that out, and that, everything is a bit of a duality. It's important to think about the negative, but let's not forget about the positive, the opportunities that we can make happen as well.
Yeah, great point. And there's probably some cases where, coming back to this question of the value of data, where companies are sitting on data that could actually be, potentially quite useful for some of these objectives, some of these 17 objectives from the UN, the Global Development Objectives. So it would be interesting to see whether there's data that's kind of being underutilized, that maybe companies could be, if they were properly informed, would be open to also sharing those databases, because that's somewhat different than sharing that with a company that's going to be a potential competitor. Here we're really talking about making use of data that has some commercial purpose, but then can also maybe be used to inform better governance. That would be an interesting area to explore. So Neil, just a few wrap-up questions here. The first is, I know that you're involved with a lot of companies. Is there a young company that's kind of under the radar that's doing something particularly interesting that you'd like to put a spotlight on?
There's probably a few, but if I had to pick one, I would actually call out a company called Cyrano.ai. That's like Cyrano de Bergerac. It was actually started by two guys, one who's a therapist and one who's a neurolinguist. And their goal was to try and help depressed and suicidal teens. So just as an aside, loneliness is actually the biggest illness in the world. About 40% of people suffer from some level of, moderate to severe loneliness. And so what they've actually done is they've been working, and they've actually created an AI engine that through conversation can actually assess the intent and commitment of a person. So through the word choice and those types of things. They're doing this to try and obviously help depressed and suicidal teens, but they realized it's probably a dangerous place to test their technology. And so they've gone into more innocuous areas like car sales, because they figured if they fail, the worst thing that happens is a car doesn't get sold. But it's actually been incredibly effective. And what they've realized is, as a whole, they've actually built a communication tool for us, for people, where not only do you gather kind of the intent commitment, but you kind of get the artificial empathy and the better read empathy. So you could actually now talk to a person and use language and words that's arguments that's going to resonate. So rather than, you may be a very fact-focused person, you throw a lot of facts, but they might be a very kind of nurturing, emotional person where they need more reassurance. So they've effectively built a tool that if you're a parent talking to a child, or you're trying to help out a suicidal teen, or you're trying to sell a car, you now have a communication tool that makes you become a more effective communicator, because it can coach you and help you understand the language and words and information to focus on that's going to most strongly resonate with that person.
Next question, Neil. Is there technology that's not yet widely adopted, but that you see as being potentially very disruptive? And by this, I mean more of a specific technology, because if we think about AI, AI is kind of a large concept, but underlying there are a lot of Kubernetes. There's a lot of different technologies that might somehow be useful. Is there anything that you see as being potentially very impactful in the coming 5 or 10 years? Could be general. It doesn't have to be related to AI in particular.
That's a great question. It's a hard one to answer because there's so much great opportunity out there. But I'll actually go in a different direction on this one, where I think neuromorphic chips could be a huge game changer for us. Neuromorphic chips is basically the machine learning, the AI intelligence is actually built into the hardware. So you don't actually need an internet connection to use it. So you don't have the latency, you get quicker response time. But one of the reasons I'm actually excited about this is that past 30 years, there's been a lot of focus on software and not so much on hardware, and that we've actually kind of hit the limit. We have actually hardware constraints now, and we're able to do. Which is why I hear a lot about like quantum computers and 5G and even 6G and telecommunications. But if we always talk about the holy grail of having your own personal digital assistant. Imagine that you don't really need an internet connection to be able to use that. You literally have that with you, whether it's on your phone or integrated into your body somehow. You can access with your mind. That will become a reality because of neuromorphic chips. And I will tell you, DARPA has spent a lot of money, I think probably close to $500 billion to try to make that happen. And you have a lot of companies, big and small, like Intel and IBM and HP, as well as several smart startups like Sentient, that have made great strides. They're only, I think, on like stage 3 or even stage 4 of the DARPA challenge here to make this a reality. And so, you think about all the sci-fi, the movies, the books, or if you watch Black Mirror about having that little AI assistant that's your personal buddy and knows everything. Neuromorphic chips will be a big step in trying to make that a reality.
Yeah, incredible. Do you have a viewpoint into a timeline for when these might be on the market?
Oh man, Eric, I wish I knew. I really wish. If I had to guess, I'd probably say we're probably 12, 15 years out. But one thing I've learned is this technology develops much faster than we realize. So, maybe it's 12, 15, maybe it's 8. I don't know, but let's stay tuned and see what happens.
Well, Neil, really been a pleasure to talk to you today. I really do appreciate your time. What would be the best way for people to get in touch with you if they wanted to have a conversation?
There's a couple of different ways. I mean, they're very happy to go to my website, neilsahota.com. There's a way to contact information to reach out to me, or you can connect with me on LinkedIn or Twitter. My Twitter handle is @Neil_Sahota. I'm constantly posting, sharing information, checking my messages. So if you want to chat, want to ask some questions about some ideas, always happy to help.
Awesome. We'll put those in the show notes. Neil, thanks so much.
Hey, my pleasure. Thanks for having me on, Eric.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT1HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@iot1.com.